Okay, here's a cubic functions test from chapter 3 from Heinemann. Let's have a look at these questions. Question 1, the remainder when 2x cubed minus 3x squared plus 5x minus 4 is divided by x minus 1. Here all you have to do, because all we have to do is substitute the value of x equals 1 into this equation. Right, so that's what it means here. You should look at this. We're saying this is a factor. We're going to divide it into there. There will be a remainder in this case. So it's not a factor that will divide evenly into the cubic function. But we look at the factor, or what's given here, and remember we look. This is negative 1. So what we're going to substitute into the equation is 1, which is the opposite to negative 1. Right, so you're going to get 2 times 1 cubed minus 3 times 1 squared plus 5 times 1 minus 4, and that will you'll get 2 minus 3 plus 5 minus 4. So when you add it together, and 2 and 5, we add the positives first. 2 and 5, you get 7, and the negatives now, negative 3, negative 4, you get minus 7 as well, and so you get 0. So the answer is, in this case, it is actually a factor, and the answer is B. Right, that's the answer. So all we did here was to substitute the value of 1 into the function here. Alright. Okay, so just having a look at question 2, here I think they want us to expand this equation. We're not going to waste any time, so we'll just use our calculator. So we'll put in the equation. So it's x minus 4 close brackets raised to the power 3 and then plus 8, enter. Okay, that's what we get, and we can see that it is close to this response B, but it's not exactly, because this is a minus 55, and here we have a minus 56. So it is not response B, even though it's quite close. So let's have a look at response A. We can sort of put this in the calculator, but sometimes it doesn't work. Right, it won't expand it for us, the calculator. We'll try it anyway. So it's x minus 2 open bracket, what we have x squared minus 10x plus 28, x squared minus 10x plus 28, close brackets. We enter that. Doesn't actually expand it for us, so we have to sort of do that manually, and we'll have a look at it. So we'll do it manually. Where am I? Yeah. Right, so we've got x minus 2, x squared minus 10x plus 28. Expanding, just normal expansion, so x times x squared, x cubed, x times minus 10x, you get minus 10x squared, x plus 28 is 28x, then minus 2 times x squared, minus 2x squared, minus 2 times minus 10 gives you plus 20x, and minus 2 times plus 28 will give you minus 56. so you can see we got what we want. This is x cubed, simplifying, minus 12x squared plus 28x, and it's minus 56. So we can see it's the same as the calculator, how the calculator has expanded it. So that is the correct response. So that response is going to be response A, sorry. Okay, going to the next question, question 3. Right, I'm just going to rub off some of this stuff because it's sort of getting in the way. Right, question 3. Okay, the graph of the function y equals x minus 6 squared. Anyway, this equation here, the best thing to do is put this into the calculator again. So this time we're going to graph the function. So we need to graph it. Let's have a look what it is again. So it's x minus 6 squared. Oops. There we go. So it's in brackets x minus 6 squared, and what's the rest of it? X minus 1. X minus 1. And we graph that. Right, we want the turning points. The turning points you can sort of see. If we want to work that out, we can go menu, analyze graph. We want to get the minimum point. Right, minimum point. So minimum point is at 6 and 0. So any graphics calculator will actually do this for you. So minimum point is 6, 0. So what's the question asking again? It has a turning point, does not have a turning point at negative 6, negative 1. No, it does not. You can see from the graph that's not true. Right, the other turning point's up here somewhere. But anyway, just by looking at the equation, we can see the turning. It has a. Let's look at response B. It has an x-intercept at 1 and 6, and a turning point. It does have a turning point at 6, 0. Does it intercept at 1 and 6? Let's have a look at it. It sort of does. It doesn't intercept though. It has a turning point. Doesn't really intercept. It intercepts at 1. Alright, so C is intercept at 1 and 6, and that's not true. Intercept at negative 1, that's not true. It has a turning, and that's not true. So the best response here is intercepts at 1 and 6. It touches 6. Intercepts at, it does intersect at 1. It touches at 6, but there's still intercepts. And it has a turning point of 6 and 0. So that's our response here. Response B. Okay, having a look at question 4 here. Right, it says the basic y equals x cubed graph is reflected about the x-axis, translated 2 units to the right and 3 units down. The equation of the image is, right, so right now if we have our graph, we have x equals and y equals x cubed, then it's a sort of an inflection type. It is an inflection type graph. Right, it'll go like that. Now I haven't drawn a Bernoulli. It has to be like the gradient has to be 0 here. But anyway, if it is reflected on the x-axis, then it would have you'd have to have a negative sign in front of the equation. So what happens is the x-axis, this axis here, becomes like a mirror, and so what you see, the mirror will be this, right? So if you're seeing a mirror of that, then it'd go like that, wouldn't it? Sort of thing. And then if you're seeing a mirror of this one, then it would go like that. Right, since the shape going to the positive, going upwards as well as going downwards, the shape is the same. Right, it's got the same proportion. So really, it's also reflecting. If you look clearly, it's reflecting on the y-axis as well. So by putting a negative sign in front of the x cubed here, it does reflect on the y-axis, but you might get a question where it says, oh, does it reflect on the y-axis? So in this case it does, it reflects on the y-axis, on the x-axis, but due to the shape of the inflection graph, it does reflect on the y-axis as well. Right, so by saying it's reflecting on the x-axis, it does have a negative sign in this case. So firstly, it has a negative sign in front of the equation. Translating 2 units to the right means that, remember, if we translate to the right on the x-axis, that means we need to go the opposite to what we have. So it's 2 to the right, going this way, going in the positive direction. That means with the translation, with the to show it on the equation, it has to be negative, right? Negative relevant to the x. So basically, you ask yourself, what if I want to go to the right? If I want the equation to translate to the right, I have to ask myself, what will make this part equal to 0? And then 3 units down, when we're going 3 units down, in this case, if we translating along the y-axis, is the sign is as you see it. So if it's 3 units down, that means we're going negative. Down is negative, and up will be positive. So in this case, the best response in this case will be response C. Okay, so it's negative, it's the reflection on the x-axis. Here it's translated to the right. Translated to the right. This is opposite to what we see. This is negative. And the translation on the y-axis is as the unit is the sign is as we see it. So if it's negative 3 here, that means it goes down 3 units down. So it is response C. Do it in red. So in question 5, we basically have to do a finite difference, and after we'll see how many steps it takes before the differences are the same, and this will tell us what order the function is going to be. Right, so we start with we got 4 and 12. So the difference between 4 and 12, we'll start 12 and 4. Difference is 8, and the difference between 18 and 12 is 6, and the difference between 16 and 18 is negative 2, and the difference between 0 and 16 is negative 16. So that's our first step, right? And then we go to the second step. We calculate the differences. So the difference between 8 and 6, or 6 and 8, is negative 2. Difference between negative 2 and 6, so it's negative 2 minus 6, so you're going to get minus 8. and here negative 16 minus 2, so it's going to be negative 14. So how that works is like this. It's you take this, for the example, the last one was negative 16. Take the last figure minus the previous figure minus 2, right? That makes a plus, and so you get minus 14. Just got to be careful with negative signs. Now again, right, the third step, the third differences, minus 8 minus 2 will give us minus 6, and negative 14 minus 8, just do it here so show you carefully, minus 14 minus 8. Right, these are where the biggest mistakes have been made in the signs, the negative signs. So it's going to give you negative. It's going to give you negative 6. So you can see the differences here have become the same. So it is a third order function. So it must be a cubic. Right. Next question. Question 6. Okay, this is a cubic function. Of course, we know the cubic function has this order. Right, it's a polynomial form, so the three factors will be x minus a, x minus b, x minus c. And a, b, and c represent the intercepts. So you can see here that the first one is a. Right, a is going to be minus 4. Right, so we put that in. A is going to be equal to minus 4, and b is at minus 1, and c is at 2. And you can see also that the a positive cubic graph, right, starts from above, comes down and crosses the axis twice if there's intercepts, or 3 times if there's intercepts. So a negative cubic, right, it comes from below. So this one's coming from below, you see? Coming from below, not from above. So the normal cubic graph comes from above, right, which is positive. So this one is it's going to be a negative cubic. So I must also put a negative sign with my equation. So in the end, I'm going to get y equals negative x. This makes a plus, so just going to be careful there. Right, it's a plus, 2 negatives there. In between 2 numbers makes a plus. So it's going to be positive 4, x positive 1, and x minus 2. Now, because of the negative sign here, you can see one of the responses. Now, it's not this one, not response A. It is not response B. It could be response C because we got x plus 4, x plus 1. It could be D because it's x plus 4 and x plus 1 and x minus 1. But because of the minus sign here, what happens is that change these two terms around. So what they've done is you got minus, and you bring this to the front. Plus 1, and so this we can write it as, we just change the signs of both of those two terms, and we have it like that. So here you just got to be careful of the signs. So if you get negatives, 2 negatives together, you get a positive. So our response for this one is going to be C again. No, sorry, not C. What's wrong with that? Not C, it's E. Because here there's a negative sign in front, so it's not C, it's E. Right, going on with question 7, just want to get rid of some of this stuff. Just stop the recording for a second. Right, next question, question 7. Alright, we're looking at a quartic as of the polynomial form. It has factors, and we see one of the factors is squared. When you see a factor is squared, it means that if it's a quartic or a cubic, it means that it touches the axes. You know, if it was a cubic, for example, if you had something like this, right, x minus 1, x plus 2 squared, then what it would mean, it actually touches the axes. So in this case at minus 2, it comes up here, goes across, and oops, did it wrong. Right, goes through the first intercept, and it'll come and touch there at x minus 2. So if one of the factors is squared, that means it will be touching. So here this is counted as one intercept, not two intercepts. Right, one intercept. Right. So in this case, if we can count, this is a very easy question. So this x term here, that this is also an intercept, so it would be like x minus 0, right? The intercept will be at 0. So that would be 1. So if we count them, that one is 1, right? The factor which is squared, it's also just 1. So there's two intercepts so far, and this last one makes 3. So there's 3 intercepts, 3 x intercepts. So that's the answer. That's the response for question 7. That was quite an easy one. Right, the graph of the function with the rule has a point of inflection. So this is a cubic of the inflection form, right? Cubic of this form, and it's just been translated and it's been also reflected on the x-axis. Right, so it's asking where the point of inflection is. So the point of inflection means that because of the translation, right, the 3 tells us, right, the 3 tells us that it is going to the right 3, and the 1 tells us going it translated up 1. So you can imagine that we're going up 1 and across 3. So up 1 across 3. So a virtual, like the virtual the imaginary axis is at, and that's at that point there at 3, 1 is the point of inflection. So our virtual axis is there, and that's the point of inflection, is at 3, 1. And remember, I've drawn it wrongly there because there's a negative sign and it will be reflected. So, but we don't need to draw any further. We don't need to look any further. So here again, the point of inflection is at 3, 1. Okay. Right, now this question here is asking for the range. Now the range, firstly the range, by definition the range is all the y values, right, associated with the graph. Associated with the graph, right? And sometimes you ask for the domain. In this case, you're not asked for the domain, but anyway, just for definition purposes, the domain is all the x values associated with the graph. yeah, with the graph, right? So to find the range in this case, we can draw the function. This is basically a quartic. Remember, a quartic. Let's get rid of some of this stuff. Right, so a quartic is similar to a parabola, except that if we had y equals x to the power 4, it's similar to a parabola, except that it is much steeper, and as it comes close to the origin, or to 0, x equals 0, it becomes more flat. Right, it's more flatter than a parabola. I haven't drawn it well here. Anyway, becomes more flat, and here what's happening is just a translation downwards. So your quartic will look like this. Right, so we imagine we move down our axis, a virtual axis. You always draw the same graph over and over again. It's just that the axis, or the virtual axis, moves. Right, so here we go, and it becomes more flat as coming towards the origin, or the point of the translation. Right, so if the range is all the values, all the y values associated with the graph, we can see with this graph that it is starting at -1. So this is the y-axis here. So all these values from this point here are the y values associated with the graph. So we'll use our terminology. So we're starting from -1, and we're going all the way to, it keeps on going to infinity, because you can't touch infinity. That's why this bracket's curved. Oops. Right, so our response for that one is D. Right, so in this case it is a simultaneous equation type problem, but we just have to transpose it a little bit to get into the right form. So we transpose this, we're going to get 0 equals x cubed minus 2x squared plus 1. So it's in the form of a cubic. Now if you don't want to solve this manually, you can just put it into the calculator. Right, put it into the calculator, and we'll just find the intercepts, and this will give us the solution to the problem. Right, so we're going to this time draw the graph. Draw the graph, comes up. Yeah, there we go. And so the equation was x cubed. Right, just forgotten what the equation was. So the equation was x cubed minus 2x squared plus 1. Okay, minus 2x squared plus 1. Right, and then we draw the graph, and we want to find the intercepts. So the intercepts will give us the solutions. So you can see here there's going to be 3 solutions. We look back at the response. The only response that has 3 solutions, actually it can be response B or response E. Right, response B or response E. Now, okay, we'll just look at the go back to the calculator, and we're going to just find the intercepts. Intercepts will give us solutions. Alright, so firstly what I want to do, I just want to blow up the area first. And again, any graphics calculator will do this. Right, even the old one will do the same. Right, they all do the same stuff. right, and I want to find the 0 points, so that gives us the intercepts. No, why is doing that? Okay, so that's the first one there. Right, it's at 1.62. Okay, do the same thing. Analyze. I want to find the 0. The other one is here. Right, that's 1 and 1 and one is the other intercept is 1. The last one. Right, so the calculator helps a lot with these sort of questions. As negative, it is negative 0.661. So I will just write them down. So we got 1, we got negative 0.62 approximately, and 1.62. Right, so it's close except for the 2 at the end, so decimal value. Now this could be a closer, we don't know, it could be a closer solution. So we'll put this into the calculator. I'll use the calculator again. So it's 1 plus or minus square root of 5 over 2. Put it in the calculator just to make sure. But I don't think it's that one. But anyway, just to make sure. Okay, just to check, we can solve it using the calculator in a different way. If you go menu, then you go algebra, solve. This is just to check that the answer is right using the graphical method. So you put the equation in. So it's x raised to the power 3. What I say was, it was negative, no, just delete that, negative 2x squared plus 1 is equal to 0, and we want to find the x values. So this is just another method to solve using the calculator, and it gives us right, because there's those values there. Now that's different from what we see actually. Right, so we go back to our solutions. Okay, now x, yes, E would be a better response. E would be a better response because this is what we got using the calculator. So this is what we got using the graphical method. Now I'm just going to fix up my calculator here, change the settings. And I want to change this to look. Yep. Right, I want to change this from auto to approximate. Okay. And go back to and if I enter this again, I should get right what I had using the graph. So that is the correct response there. Right, so if we go back to the responses that we see on the test, so it will not be response B, because response E is more accurate. So using the graph, we had 1, negative 0.62 and 1.62, and so response E gives us a better answer. Right, moving on to the extended answers. You can see this question here is the profile of water for water slide can be modeled by the equation. It's a cubic function and it is of the inflection form, not of the polynomial form, and it's between 0 and 20. Right, so we're not going to muck around. We'll go straight on to using the calculator because it sort of looks a bit complicated. Get our calculator out and we're going to graph it. Right, so our function is going to be minus 2 minus what do we have? We had in brackets x minus 40 close brackets cubed. I think I'm missing x here. Right, and here, oops, it's quite sensitive. So here I want to put 5,000 and I want to enter the graph. Right, just I'm going to blow it up or zoom in. I want to zoom out, sorry. Zoom out. Right, and I want to look at this region here, so I'll just zoom again. Just want to look at this region here. Okay, so that's the graph. Right, it crosses the x-axis and the y-axis, so we want to find, there's two ways to do it. We just use a trace graph. So right, we got an intercept at 18.5, x-intercepts 18.5, and we go up towards the y-intercept, and we'll find it's the y-intercept at 10.8. Right, so we can draw our graph now. So here's sketch the graph of the equation that models the water slide. Label all the intercepts and endpoints correct to one decimal point. Right, again, I'm just going to draw this very quickly. Right, use red for the axes. Right, so here we said it was 10.8 on the y-axis, and here 18.5 on the x-axis. Alright, make sure you label your axes as well. And we'll go all the way to 20, so at 20, its value of at 20 would be, right, so I need that endpoint as well, so I have to make sure I mark the endpoints. Right, so I go back to the calculator, let's have a look, and I just go down across until I get to 20, 21.1, so right, I want an actual figure there, so maybe we can put it in, analyze, I could do it manually, I guess, but I will use a calculator. Alright, go to menu. so at 20, at y equals 20 will be, at x equals 20 will be minus 2 minus x equals 20 minus 40 cubed, and it's 500 into negative 0.4. So at 20, x equals 20 here, the graph will go down to negative 0.4. Right, so I'll draw my graph in. Right, so we need to go from 0 to 20. X equals 0 to 20. Right, so it's just have a look at the graph again to make sure on my calculator. Oh, it's just like a slide. Try and draw it the best you can, and down here until it gets to about there. Right, so that's question A. Right, fine. Question B is find the value of D corrected 2 decimal places given the slide is less than 8 meters above ground over the interval of D to 20. Right, so we want to find the value of D where the slide is less than 8 meters. So there's 10.8 meters, so 8 meters is going to be around about there. So we just put it into the equation. So where y is equal to 8, right? Where y is equal to 8, that's what it's wanting. 8 meters high, where it's less than. So we want the value of D. Whereabouts is D? Where y equals 8. That's what we want. Right. So we let. So here, just you let y equal 8. Right, so go back to the equation. Y is equal to 8 equals negative 2 minus x 40 cubed, and over 5,000. We can solve this manually, right? So, or we can actually use the calculator, but it's best to use the calculator. It's much quicker. So again, we go to the menu, use algebra. We're going to solve, put the equation in. So we got 8 equals, I'm going to say it was negative 2. Oops. Negative 2 minus, got negative 2 there. No. Oh my god. Negative 2. Right. Open brackets. X. We will solve for x, so this is what we have to put in there. Minus 40. raised to the power 3. Very sensitive calculator. Actually my touchpad is a bit sensitive. And go here. Oops, very sensitive. Comma. And we're going to solve for x. Right, so let me enter. So x equals 3.15. Right, so that's 3.15 or 3.16. So at x equals 3.16. So d, the value of d is 3.16. Right, go on to the next question, which is question 2. Right, here again we're using finite difference and data collected from a tracking device can be used to analyze the flight of an eagle while it's swooping for prey. The height above sea level h in meters of an eagle at time t seconds was recorded at 1 second intervals in the table below. So use the finite difference table to show that the eagle's flight path can be modeled by a cubic. So we need 3 steps, right? So we need 3 steps. 3 steps for the differences to be the same, right? That means we will have a third order function, and it will be a cubic. So that's all we're asked to do. We're not asked to work out what the equation is. So again, it's 40 minus 98 is 58. 40 minus 58. 3 minus is minus 37. 14 minus 3. 14 minus 3 is 11. 100 minus 14 is 86. And 288 minus 100 is 188. Right, so it's first order, second order. Right, so negative 37 minus 58. Right, it's going to be a positive, so it'll give me 20, 21. 11 minus 37. Right, it's going to be positive 48. 86 minus 11 is going to give me 75. 188 minus 75 will give me 113. Right, so this is first order, second order, and the third step, right, should get us the differences to be the same if it's a third order function. So right, so I go 48 minus 21 is 27, and we see that 75 minus 48 is also 27, and 113 minus 25 sorry, it's 28, so this I was wrong here. This should be 112, so not 113. That's 112, and then we get 27. So they're all the same. So that means it's a third order function. It must be a cubic. Right, next question. Okay, the eagle's height above sea level is given by this rule. Okay, show that t plus 3 is a linear factor. All we have to do is, if we substitute the value of t equals minus 3, right, this should come to 0 if this is a factor. Remember, this is a polynomial, a cubic polynomial, and to find find one of the factors, we substitute a value into the polynomial and it should give us 0. In this case, it's asking us to show that this is a factor. That means that if we substitute minus 3 into the polynomial, it should give us 0. So we just check that. So 4.3. Now I can just use my calculator to do that. So we're putting negative 3 into the equation, and I've done this previously on my calculator. So here we get 0. So when we put negative 3 into the equation, we get 0. That means that's a factor. So that's an easy question. Right, so we put negative 3 into this equation here. Yeah, we get 0. So that proves that that is a factor. Alright, question C. So it's asking us to fully factorize, but here we're just going straight into the calculator, let the calculator do it for us. Right, so I'm not going to go into a long division here. Right, so we go to solve, menu, algebra, solve, and the equation is y equals, no, sorry, is 4.5 x cubed minus 16.5 x squared is 40x. Oops. Minus 40 x 150 equals 0, and try to solve for x. So maybe I'll just change my settings. I want to get exact values. So go here, exact value. Okay. Get my current, and it gives us my exact value. So it's negative 3 and 10 over 3. So there's only two solutions there. That means one point must be just touching the axes. So when we fully factorize, that means so one of our, we said it's not x, is t. Really matter which letter you use. So it's x plus 3 is one of the factors, and the other one was t minus 10 over 3, and that would be squared, because this one you have only two solutions or two intercepts. That means one of them is just touching the axes. We don't have to draw the graph. So go on to D. Find the initial flying height. Find the initial flying height of the eagle. So t equals 0. So just put t equals 0 into there, into the equation. H t equals 0. That means the first three terms will drop out, and you're just going to get 150. That's an easy question. Right. Find the time when the eagle reaches sea level. So we've got two solutions here. When the eagle reaches sea level, that means the height is equal to 0. Now we've already solved for that, right? So we've got the solutions as when it touches the x-axis or the horizontal axis, right? So at t negative 3. Now you can't have negative time, so t equals negative 3 seconds. That you can't have that, because you can't get negative time. Right? You can't get negative time. So it must be t equals 10 over 3, which is 3.33 seconds. So F is the last question here, and it wants us to draw the graph, sketch the graph between 0 and 6. Again, we'll use the graphics calculator to do that for us. So we'll draw this function using the calculator. Yeah, we need to be good at using this calculator. It is a tool. Just like you need to be excellent at working out these problems by hand, we need to be excellent at using the calculator. I mean, we need to be good at both, you know. We need to get good at both things. So using the calculator to draw this, and then we'll see what the graph looks like. And we have the graph. Now you can zoom in, you can zoom out or in to have a look at the graph properly. Now, because we have such a small screen, it's pretty hard to see what's going on. But you can see we have showing the intercept here. This is the flight of the eagle when it reaches the sea level. Sea level means y is equal to 0, right? And we calculate that as 3.3. Anyway, we need to go from 0 to 6 to draw the flight of the eagle. So here we'll just use the trace. Right, so we'll start from 0. Right, so y-intercept is at 150. So x equals 0, the eagle is at a height of 150, and then it reaches the ground, sea level. Imagine that crosses the eagle is flying down, hitting sea level, coming down to sea level. We've gone past it maybe, no, here it is. Right, that's sea level. Right, which is our minimum. And then it comes back up, so we need to go to x equals 6. So at the moment we're at x equals, at the minimum it's 3.3. We need to go all the way up to 6. So at 6, what is the height of the eagle at 6? We can calculate this manually, but since the calculator is doing it for us, might as well use the technology. Right, so 6 is 288 meters. The height of the eagles, 288. So now we can draw it. We've got a good idea what's going on. We can draw the graph. Right, so again you use a ruler. Right, so just say this 150. That's 150 meters, and up here somewhere it's 188, and down here, right, this is our time. So this is 0 time, and we'll say this is 6 seconds, and 3.3 is about a bit more than halfway. 3.3, and right, so it starts here. Starts its flight here. Draw another colour, green. Comes down, hits, not drawn properly. Anyway, hits there and comes up to 188. So they're the endpoints. Label your axes and everything like that. Right. So this is height h, and this is t. Right, and this is 6 seconds and 288. and this is at anyway when x equals 0, y equals 0. That's it.